Hmm? No. Okay. Okay, guys. Hello. Yeah, I am going to do grade 10 revision now. Grade 10. So all grade 10s that I don't know, any grade 10s that are here that are writing paper 1 tomorrow. I believe that I have a few people that are writing grade 10 maths paper 1. I know that tomorrow is like the grand day for the grade 10s. I mean, what? Not grade 10s. What am I saying? I know tomorrow is the great day for the grade 12s tomorrow, but I don't want to be doing any grade 12 work right now because I don't want to influence anyone to doing anything that is grade 12 related at this present moment. So I'm just going to do some revision for grade 10, okay? And it seems like my great friend Lerato is like pushing the idea on functions. Okay, Lerato, I will do that if you can show me that you are capable of answering the following question. Okay. Yeah. I don't have a problem with that. Okay. So here, before I even get into functions, because Lerato is insisting I do functions, let us check if Lerato can answer the following questions for me. I want you to help me fill up the following. So I want you to help me fill up the following. Hopefully you know what these symbols means. Okay. Yeah. Hey, tomorrow, even the next day, you will be explaining. What is this Patokohle? What is Patokohle saying? Yeah. You will be explaining. What is this? What is this guy up to? Okay. So, guys, like I said, this is for those who may be wondering what's happening here. But obviously, what I'm about to do is so relevant. It's so relevant to the grade 9 learners. So if you are a grade 9 learner, you are not lost if you are actually in this live. Okay. Hey bro, just like that, a perfume just like that. Hey, thank you so much, me again. I don't know why, what is that for, but thank you. I appreciate the perfume. That is so nice of you. What is this? Close the door. I don't know what manner of bribery is this, but thank you for the perfume. I really appreciate it. Hey, it's very rare. Okay, guys, do we know what this symbol stands for? Can someone tell me what this symbol means? I want to, at the top of all of these, write down what this symbol means. It has been awesome. What is this? It's like a farewell, bid me farewell type deal. Is it because you are writing tomorrow. Yeah, guys, sorry, no, I am deliberately not doing any grade 12 work, eh? Because I don't want to influence anyone the day before. So I am doing somewhat grade 10 maths revision. I have some learners that are writing tomorrow grade 10 maths paper 1. So I'm doing grade 10 maths revision. So I'm very sorry if anyone joined in hoping that I would be doing grade 12. No, I'm not. Okay, so Landy, you said those are integers. Very good. That is a symbol for integers. What are integers? Do you know what integers are? Hopefully we do, guys. Okay, integers are what? What are integers? Hey. So we're doing grade 10 revision here, okay? Grade 9s can benefit if you are here. What are integers? Do you know what integers are? Hopefully we know what integers are, guys. Okay. Those are numbers, integers. Integers are positive and negative whole numbers. Okay, so for instance, 0, they go up by 1 from 0, which is like the neutral number. They go up by 1, they go down by 1. So they increase and decrease by 1. Okay, so 0, 1, 2, 3, you can list all the other numbers to infinity. And then the negative direction, all the numbers to negative infinity. Those are integers. Okay, so those are what integers are. This is our symbol for integers. Integers are positive and negative whole numbers. What does this symbol stand for, guys? Do you know what does this symbol stand for? What does this symbol in number systems actually stand for? So those are integers. What does that symbol stand for? Do you know? Okay. So those are natural numbers. Okay. Thank you, Landy. Seems like you're the only one that's here. Natural numbers, guys, they start at 1, they increase by 1 all the way to infinity. So this is our starting point, 1, and they just go up by 1. So 1, 2, 3, 4, 5, 6, all the way to infinity. So from 1 to infinity, increasing by 1. Integers are positive and negative whole numbers. They increase and decrease by 1. 0, 1, 2, 3, negative 1, negative 2, negative 3. So very well defined the difference between natural numbers and integers. What does this symbol stand for? What does this symbol stand for? Sorry that your network is lagging. Okay, Precious. Well, good to see you there. Thank you. Yes, whole numbers. Well, I'm glad that she is not the only one that's here. Whole numbers. What about whole numbers? What do you know about whole numbers? Whole numbers start at 0. They increase by 1 all the way to infinity. Those are whole numbers. What does this symbol stand for? So natural numbers start at 1. They go up by 1. Whole numbers start at 0. They go up by 1. Very good, Precious. The symbol here is rational numbers. The Q stands for rational numbers. What are rational numbers? Okay. Hopefully we know that rational numbers, okay, we have the fraction side and then we have the decimal side of rational numbers. The fraction side of rational numbers is where we have a numerator and a denominator that are elements of integers. So your numerator and the denominator will be integers. So in the numerator, we can have an integer that is a negative number, or we can have an integer that is a positive integer. We could have an integer in the denominator, likewise, that is a negative number or a positive number. But remember, our denominator can never be 0. Okay, denominator cannot be 0. Okay, yeah, if it does not form an integer, so if there's no integer at the numerator and the denominator, then basically then we can't say it's a rational number. Okay, for our decimal numbers, we know that rational numbers are recurring. They are repeating numbers. Okay, repeating numbers, guys. When I say, okay, so rational numbers, a over b where a and b are integers and where b cannot be 0. Because we know that if a number is divided by 0, then obviously this would look like a rational number, but it is not, because if 0 is in the denominator, we say the number is undefined. So it's an undefined number, this one. So this does not qualify as a rational number, but it's rational as long as the numerator and the denominator are positive and negative whole integers, and as long as the denominator is not 0. For decimals, we can either have recurring decimals. We know that recurring example would be like 5,66666. That means the 6 repeats. We can have 5,6 in this sense, meaning that there's a dot on top of the 6 to show repetition. Or we can have 5,7878. This indicates that there is a pattern of 2 repeating numbers. It could be 3 repeating numbers. It could be 4 repeating numbers, infinitely recurring. And sometimes, guys, instead of the dot on the top, we have a line above the repeating numbers. Okay, that's also recurring decimal. So this all falls under recurring decimal. Okay. Then the other type is terminating decimals. These are also a type of rational number. Terminating decimals is like having 5,78. You see this 78, it stops. So second decimal place, or 2,3. First decimal place. That's a terminating at first decimal place. So when you round off, all rounded off numbers are actually terminating decimals. Okay, so I hope that makes sense now as far as our rational numbers. So rational numbers are numbers that can be written as a fraction, where the numerator and the denominator are what? Are integers, but the denominator cannot be 0. They can be written as recurring decimals, where the decimal number repeats. It can be 1 decimal that repeats, 2 decimals that repeats, 5, 6, depends on the pattern of numbers that repeat. Terminating decimals are decimals that come to a stop or a halt. Okay. So that's rational numbers. What does this symbol stand for? What does this symbol stand for? Not comma 8 dot, or not comma 888888, or not comma, yeah. What does this symbol stand for? Thank you, Landile. It is irrational. Thank you. Thank you so much for that. That's irrational numbers, and irrational numbers are the opposite of rational. Okay, they are irrational numbers. So irrational numbers are the opposite of rational numbers. Irrational numbers, they are non-recurring and non-terminating. So that's why, for instance, if you have if you have the square root, for instance, of 3. The square root of 3, if you put this into your calculator, you are going to get a decimal number that is, meaning in other words, there's no repetition in the comma when you get that answer in the calculator, and it's non-terminating, meaning the numbers don't stop, they go on forever after that comma. Okay, no repetition, no stopping. No repetition, no stopping. There's no pattern in the numbers, there's no repeated numbers, like that forms a pattern, and there's no stopping. So like the square root of 3, the square root of 2, the cube root maybe of 7, and so it goes. All these numbers inside the square root are non-perfect square. They are not perfect square numbers, but you will find that for rational numbers, so for instance, the square root of 25, that will actually give us 5, and 5 can be written as 5/1. So this is a rational number. Okay, all right, guys, very good. Thank you, Landiwe. What does this symbol stand for? this one, and then obviously that one. Let's attack these both. What does this symbol stand for first? The R without an apostrophe. Not about the R with an apostrophe. So the R without an apostrophe stands for, this is real number. Okay, yes, Landy, very good. And this stands for non-real. Okay, I think we're good, guys. Real numbers means all of these numbers, the entire family here. Integers, natural numbers, whole numbers, rational numbers, irrational numbers, all are real numbers. In other words, the family of rational and irrational numbers forms the entire family of real numbers. This is the real number system. That's what we mean by the real number system. It's everything here included. Integers, natural numbers, whole numbers, rational numbers, irrational numbers. That's the entire family of real numbers. The non-real numbers, they are very special, these guys. Any square root of a negative number, okay, is what we call non-real. Any other even root, let's say fourth root of any other negative number, as long as that particular negative number is even, that negative number is under the even root. If it's under the even root, it's a negative number, then it's non-real. Okay. And guys, as I've said many times, division by 0 is not non-real, it's undefined. That is different from non-real. Undefined and non-real don't mean the same thing. So yes, when you put this in your calculator, you get maths error. When you put that into your calculator, you also get maths error. But this one means non-real, this one means undefined. I hope it's clear. Hope we get it. So I want you now to work with me and tick the relevant box for the following. And let's see. Let us see. Let us see. Okay, let's check. 3. Can we tick that 3 falls under integer? Is it a natural number? Is it a whole number? Rational, irrational, real, non-real? Can we tick here? Okay, Landio says yes. Okay, I hope we can, and everybody agrees. Okay, so we can tick there. Can we tick there? Is 3 a natural number? Okay, yes. Whole number? Okay, yes, very good. Rational number? Okay, yes, and then is it irrational? Can we tick there? Is 3 an irrational number? Okay, no. Alright, I think you get the point, Landielene. And rational, okay, so obviously it will be real, and then it's not non-real, so we're not going to tick right there. So we've ticked everywhere except non-real. What about pi? Is pi an integer? Pi. Can we tick pi as an integer? Okay, we can't, eh? Very good. Pi is not an integer. Is it a natural number? Yes, we'll do. Okay, no. Very good. Is it a whole number? I thought let me just invite you and we can just talk about it, London.
Can you hear me?
Yeah, very well.
Okay.
Yeah. So I'm just So this is just a warm up. I think I'll get into what you would probably want me to do. You're the one that inspired me to come and do the live, anyways. Okay, so we said it's not an integer. It's not natural. Is pi a whole number?
No.
Rational?
No.
Okay, it seems like you thought for a moment there. Why did you hesitate?
I was thinking if it has recurring numbers or non-recurring numbers.
Oh, okay. Okay, and what was the conclusion? Doesn't.
Yes, it doesn't.
Okay, then irrational?
Yes, it is
Yeah,
irrational.
definitely. So I guess that's the only option. And then did you say irrational?
Irrational.
Oh, okay, irrational. Okay, real?
No. Is it? Yes, it is. Okay, yes, it is because it's an
Okay,
irrational number.
definitely. And is it non-real?
No.
Okay, let's come here. Now we have the cube root of 24 over 3. Is it an integer?
No.
Okay, so I'm going to back up a little bit. What is 24 over 3?
It's 7. I think it's 7.
Are you sure?
Is it 7? Let me check, sir.
Please do. 24
Oh, it's 8.
And then what's the cube root of that 8?
Oh, it's 2.
You see? Yeah, so what we need to always do when we have these numbers, now I would always advise to just put this in your calculator and check, because you want to verify most. Yeah, if you look at this number at face value, you could easily think, it can't be an integer. Definitely not, because it's a fraction. But then simplify it, you'll be shocked.
Yes, sir.
Yeah. So is it an integer?
Yes, sir.
Yes. So is it a natural number?
Yes, sir.
Is it a whole number?
Yes, sir.
Rational?
Yes, sir.
Irrational?
No. Yes. No.
Yeah?
Is it, sir?
Is it irrational?
No.
Okay, definitely not. Remember, if a number is rational, it can't be irrational.
So why is the 3 rational and irrational?
Exactly.
Has it ticked it?
Exactly. That's a good question. So yeah. So I guess you tell me, is 3 rational?
Yes, it is rational.
It's
Because
rational.
it can be written as a fraction.
Is it irrational?
No.
Okay, so that's out. I think I did a Kevin mistake there. All right. Is it a real number?
Yes, it is a real number.
Awesome. And then is it non-real?
No.
Okay. So rational and irrational are opposites. Real and non-real are opposites. So if it's one, it cannot be the other. Okay, now we are here. Square root of -8. Is it an integer?
No, sir.
Where should I tick then? You tell me. Square root of -8. Can I tick anywhere?
Non-real.
Non-real, ne?
Yes.
Okay. So that means everything else is empty. How wonderful. Then the very last number we want to look at, the cube root of -27. Is it an integer? Or what's the number first? Let's start there. Oh yeah. You're welcome. Oh yeah.
So what was he saying?
The cube root of -27. What is it equal to?
I think it's also a non-real. I also think it's a non-real number.
Just check it first. In your calculator, the cube root of -27 gives you. I love the fact that, at least you're experiencing, Lanti, what I usually experience with my background with the kids.
Sorry, sir. It's an integer.
It's an integer. What is the answer first? What's the cube root of -27?
-3.
Awesome. So -3, is it an integer then?
Yes, sir.
Okay, natural?
No.
No. Whole?
No.
Irrational?
Yes, sir.
Irrational?
No, sir.
Real?
Yes, sir.
And then non-real?
No, sir.
Okay, awesome. I think you've got numbers down. Okay, so I'll hand that over to you. Okay. Okay, now I want to follow this up with this. Between which two integers does the square root of 7 lie? Which two consecutive familiar with the question, how to answer when we are asked?
Yes, sir.
Okay, so what would we do here?
We find the closest
Closest.
numbers which are square roots.
Okay, and those numbers which are under the square root, we call those numbers what?
Ah,
We said we find the closest numbers.
yes, sir.
How do we find those numbers?
Oh, I don't remember, sir.
Okay, so the square root of 7 is there. Oh, nice. Okay. So we want to find a perfect square number that comes after 7. Can you think of any perfect square number that comes after 7?
9.
Exactly, 9. Any perfect square number that comes before 7?
4.
4. Awesome. So you found them. Then we put those under the square root.
Yes, sir.
The square root of 4.
2.
And then what's the square root of 9?
3.
Does 2 and 3 follow each other as
Yes,
natural
sir.
numbers? So therefore the square root of 7 lies between 2 and 3. Okay, that was pretty straightforward and fast.
Yes, sir.
I wanna do one more with you. Let's say between which two consecutive integers does the fourth root of 11 lie? So same question.
You.
So this time around, you are not finding perfect squares. You are finding, I guess, perfect.
Fourth roots.
Yeah, exactly. Something like that. It's exactly that. Perfect. Yeah. Hello, Madineo. So yeah, the so any. Remember, if perfect squares are numbers formed by multiplying a number by itself, then those types of numbers are numbers that are formed by multiplying a certain number by itself 4 times. So for instance, 3 times 3 times 3 times 3, right? Yeah, that gives us 81, if you know what I mean.
Yes, sir.
Yeah, 2 times 2 times 2 times 2, that gives us 16, right?
Yes, sir.
Yeah, and then 1 times 1 times 1 times 1, that gives us 1.
1.
So if you think about it in that way, we have 11. Now you are thinking of a number after 11 that is a, because this one is 81. So we have 1, 16, 81, if you are looking at the order from 1, 2 to 3. So after 11, it would have to be what?
16.
Yeah. I get. And then before it would have to be
1. Yeah, 1.
Yeah. So therefore, what is the fourth root of 1? It is 1.
1.
What is the fourth root of 16?
2.
Yeah. Therefore, the fourth root of 11 lies between 1 and 2. Okay, sorry. You put this under the square root still. I wasn't supposed to. It's supposed to disappear. Okay. I think that's a bit of like understanding. Okay. So that's kind of like the logic behind how we find these numbers. Okay. Okay, I want to do another number type question. Look at this. Have you ever seen a question like this? I want to see. It's you're given an expression, square root of x over x minus 5. And then the question says, for which values of x will the given expression, let's say 1, be undefined? Okay, so for a grade 10 learner, these are also some common questions you get, like your beginning questions. So if you get, because remember, for algebra and equations, that aspect for grade 10, there's in a paper 1, you have 30 plus minus 3 marks that is devoted to that. And then underneath that, you need to understand that real numbers can be rational or irrational. You then need to be able to establish between two integers, and a given simple surd, and where those two, between which two integers, that surd, and by surd we mean this, where does it lie? And then you need to be able to round off real numbers to an appropriate decimal place. But also, as part of understanding real numbers, this comes into play. So you have square root of x over x minus 5. And the question is, for which values of x will the given expression be undefined? So how would you answer this question if you were to be asked it?
We substitute the denominator x by 5.
By 5.
So that it becomes 5 minus 5, which is 0.
Okay. So then the question still stands. For which value of x will the given expression be undefined? So what will be the value of x that will make this undefined? What would be your answer here?
5.
It is when x
is equal to 5.
Exactly. Okay. So I hope you understand that. I like what you said. You said you look at the denominator, because when we talk about undefined, we are talking about where possibly we could have 0 in this denominator. What value of x would make that possibility a reality? It's when, if we take that denominator, we equate it to 0, we find that x is equal to 5 is the value of x that would make that denominator undefined, or in fact the entire expression undefined if x is equal to 5. Okay.
Yes, sir.
I think the understanding is down. Then 2, for which values of x will the given expression be non-real?
I'm still...
Remember, what is a non-real number?
It is a number that is square root negative.
Okay.
I don't know how to explain it.
No problem. No, I get you. So basically, it's any number underneath a even root. If that number underneath the even root is negative, then we say it is non-real. So for this situation, if you look at the numerator, that's where we have a square root. If we have any x value here that is negative, that basically means that this entire thing is what? Is non-real.
Non-real.
So if any value of x here we take, so if we have a question like this, we always go to where the square root is. And then underneath that square root, we take whatever expression is there, and then we just say less than 0. Remember, if any x value here is less than 0, now give me any value that's less than 0 that you can think about.
-1, -2.
Exactly. You see, so any value less than 0 that is plugged in here will make this entire expression less than 0. So this is very important. Okay, I just want to give you another sort of like, let's say we had an expression like this. Let's say it was x plus 5 over x plus 3, and they had asked the same question. For which value of x is the expression non-real? What you would do is you would say, okay, what does non-real mean? You know that it means when you have a negative number underneath a what? A square root. You would take the expression underneath the square root, which is x plus 5, and what would you do? You would say less than 0. You remember this? This is an inequality. So when you solve an inequality in grade 10, you simply take the 5, you transpose it. So that means when x is what?
-5.
Less than -5.
Yeah,
now think about values that are less than -5. Just give me one example of a number that is less than -5.
-6.
Listen now, if you take that -6, you plug it here. What's -6 plus 5?
-1.
So that answer underneath the square root was negative. That makes this entire thing non-real. Makes sense? Another number less than negative, right?
-7.
Exactly. -7 plus 5 is also -2. Another negative number. So any of those values less than, there's an infinite number of numbers that are less than -5. You substitute them there, the whole entire family of these numbers, you substitute them there, they will make this thing a negative number, therefore making this non-real. Make sense?
Yes, sir.
Okay, for which values of x is the expression undefined? Remember, undefined, we would go to the denominator. So for non-real, we go underneath the square root. For undefined, we go to the denominator. For non-real, we go to the expression underneath the square root. We say less than 0, we solve the inequality. For undefined, we go to the denominator. We take the expression, equate it to 0, solve. Whatever that value is that value that we'd substitute to make this what? Undefined. So undefined and non-real are two distinct concepts. You need to know those concepts, grade 10, moving forward, 11, 12. Okay?
Yes, sir.
Yeah, I think like you are numbered up. I want to do this one and then I will leave. I promise you, after these two, I will leave numbers. Show that 2,3 is rational. How would you do that? Show that 2,3. He has a dot. What does this dot stand for on top of the 3?
Recurring.
Okay. Now, how do we show that this here is a rational or is rational? Do you remember what we said about a rational number? We said a rational number is a number that can be written in the form of a fraction, where the numerator and the denominator are what?
All elements of integers.
They are integers, and the denominator cannot be what?
Equal to 0.
Okay, listen up now. Basically, what they are saying here is they are saying convert this to a what? Basically, to a
fraction.
Can you do that for me? Are you able to convert this to a fraction without using a calculator?
I can try.
Sure. Let's see. Lead me,
So first,
lead me.
let's let x be
Let x be
2,3. Recurring.
All right, thank you. All right, I've done that. Yo, step number 1. I'm proud of you. We're smiling.
Then step 2.
Mm.
Yo.
You.
Yo. I don't know.
Step number 2.
Or we use 10.
Okay. And if we do that to the left, that means we move our comma
1 unit.
because we're going to multiply by 10. If we're multiplying by 10 here, it means x becomes 10x. We multiply by 10 here, it means we move the decimal by 1. So now we have what? 23, comma.
3.
Okay, what's the goal of doing this? The goal of doing this is having same numbers after the comma.
Yes.
Because if multiplying by 10 does not achieve that for equation 1 and 2, we go on further, my friend. Yo, Tina.
Or you go to the 100.
Look at this. How many times from the original one? 1, 2. So that means we have what? 233, comma, the repetition.
Yes, sir.
Yeah. So what I'm saying is we do this so that we can eventually have two equations where we can see that after the comma, we have the same thing. Now for the first equation, after the comma, same. After the comma, same. After the comma, same. Then when we have established that there are two that have after the comma the same, then we step number 3, after doing this, we subtract one equation from the other. Now you must decide which one do you want to subtract. So if I decide to subtract equation 2 and 3 because I can see after the comma, we always take the two that have after the comma the same. Now all three do have that. If I want, I can subtract equation 3 and 2. Or if I want, I can subtract equation 2 and 1. Or if I want, I can subtract equation 3 and 1. Either way, I will get the right rational fraction, okay? Because
Yes.
after the comma, we are the same. As long as we take the equations that are after the comma, that's what? The same. So let's take, just for argument's sake, 3 and 2. You could take equation 2 and 1. You will get the same answer. So let's say we take equation 3, that means 100x, minus what? Minus 10x on the left for these two. On the right, we say 233. Now listen to me. This 3 and this 3, when we subtract 3 minus 3, this will become 0. So that means I will not have a comma anymore when I subtract these two.
Yes.
What's 233 minus 23? Because that's the only thing I'm subtracting on the right hand side. Because all of these are
210.
210. Okay. 100x minus 10x?
90x.
You see, now I can solve this equation. What do I do here? I divide by 90 both sides. What I do on the left, I do where? On the right. Therefore, what's the value of x? My fraction. What's 210 divided by 90? Simplified.
7/3.
Amen. Isn't 7/3 going to be equal to this 2,333 repetition? You can take this, put it in the calculator and say SD. Behold, the 3 repeated. There it is. So
I think they asked the question there.
Sorry?
Someone asked a question.
Can we get another? Can we get another example? I don't understand why people say, can we get another example? Why can't you zoom in and see this example, the one we are doing right now? I don't understand that. I don't know. Every time I do lies and people say, do another example, I'm like, guys, what about this one? You know? Look at that. Are you kidding me? We don't understand that one. Yeah. Right corner. Okay. But firstly, Landy, I need to understand that. Do you understand it?
Yes, I do understand.
Okay. And then, Landy, wait, did you remember I said, here I took equation 3 and 2. But if I wanted to, I could have taken equation 2 and 1. Why? Because after the comma, we are the same with this one after the comma. Do you see?
Yes, I
So
can
I
see.
could have, if I wanted to, said, let's take equation 2 minus equation 1. So that means on the left, okay? And maybe you are wondering, why do I say 10x minus? I always start with the big number minus the small number. Now, if I do it like that, that means I'm going to start on the right hand side, I'm going to do the same. 23 minus the 2. So what's 10x minus x on the left?
9x.
Exactly, it's going to be 9x. Thank you very much. On the right side, what's 23 minus 2?
21.
Exactly. Okay, and maybe you are asking me, why am I just focusing on the 23 minus 2? Remember, what's 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 3 is 0. All these recurring 3's are going to, they are going to go, you see. So 23 minus 2 is 21. And then if I solve for x, I divide both sides by 9. What do I get as my x value?
7/3.
Aibo, Habi Baba, we got the 7/3 again. This thing is working, man. Okay. Yeah. So all in all, you could even take equation 1 and equation 3. Why? Because after the comma with equation 1, the 3 is repeating. With equation 3, still after the comma, the 3 is repeating. So they are illegible equations to take. I can subtract them. Does that make sense?
Yes, sir.
I don't know. Hence, I'm saying, people will say, hey, do another one. The example, what about this one? Yeah. So we are smiling. I'm personally smiling. I see an oh in the comment section. So I think we finally, you see. Okay. Then, Landile, if I say to you, round off before I officially leave numbers, because I feel like numbers, round off this 2,37818. Round off this number to 3 decimal places. 3.
We use the fourth number after the decimal.
We use the 1, 2, 3, the fourth number. Okay, this one.
Yes, sir.
So what is the number rounded off to 3 decimal places then?
Since it's less than 5, it remains the same. And okay,
So
not the
what?
same, but the answer is 2,378.
Okay.
It doesn't change anything after it.
You are 100% correct. Thank you very much. If I said round off to 1 decimal place, the same number. Okay, by the way, this is obviously a terminating decimal, which is a rational number. So if I said round off to 1 decimal place.
Lerato gave the answer.
Oh, there we go in the comment section. Nice. 2,4. Okay, well done, Lerato. Very true. Okay, so you guys get the point. Okay, why the emphasis on these things? Because in the CAPS document, when teachers teach and they are supposed to achieve outcomes in grade 10 for numbers, these are the things that are key. 3 things. Understand that real numbers can be rational or irrational. Know the difference. 2, establish between which 2 integers a given simple surd lies, like we've done. between which two consecutive integers does the third lie. And then 3, round real numbers to an appropriate degree of accuracy, which is what we've just concluded. And in the midst of all of that is all of that understanding of the real number system, undefined, integers, na, for which values, and all of that stuff. Okay, so we've basically completed the first ring of understanding when it comes to what you need to know for exam. Next up is this. Represent, before I officially represent the following on a number line. Can you do that? Represent the following on a number line. X, where x is greater than negative 50 and x is an element of integers. Nice squiggly, squarey brackets. Represent the following on a number line. Can you? That's 1. 2 minus 10. So the first one for 2 marks, can you represent that in a number line? For 2 marks, can you represent that on a number line?
I don't know, but I can try again.
These two. The first one.
Okay.
Such that x is greater than or equal to negative 50 and x is an element of integers. How do we represent that on a number line?
We draw the number line.
Here we draw the number line.
And so if x is greater than negative 50, do we include the negative 50 or what?
You tell me. This is saying x is greater than or equal to negative 50. So what do you say?
I think we don't include it.
So if you're saying we don't include it, what are you then saying to me? Speak to me. There's the negative 50.
So x will be bigger, or it will go to the right, the arrow.
It will go to the right. It will go to the right, the arrow.
Yes.
Okay, so how do I? Okay,
we included.
Tweezy in the comment section says if x is greater than or equal to negative 50, we will include it.
Oh, it's equal to So we include because it's bigger and equal to 50.
Thank you. So here we will have
a closed dot or something.
Yes, for negative 50. Then of course, it will be followed by negative 49 and by negative 49 and all the others. Well, since it's integers, it means that we are going to be playing Skippy. Negative 50, negative 49. We are not obviously taking into consideration all these other numbers. So,
yes,
yeah.
So how do we write it? We do those dots.
Yeah, on a number line, yes. You can draw these dots. Okay, I know, for instance, in the old Mind Action Series textbook, they would basically say negative 50, negative 49 because it's integers, then obviously all the other ones. And then what you would do is you would draw a vertical line and then an arrow that indicates that this pattern of integers continues in that direction.
So if we write it that way, is it correct?
Yeah.
All right.
Yeah. So this is like from the, they're not the new Mind Action series, but the old Mind Action series. That's how they would actually represent it. So unless, of course, there's a way that maybe at school when you were taught, you basically were able to write it down. Then you can maybe indicate that. But here what I've done is I've written that included for negative 50. Obviously, that negative 49 is the next integer after negative 50. So we represent that and every other integer that follows. So I then write this to indicate that this thing here of integer continues, okay, in that direction, all the way to what? To positive infinity. So that's basically how we would represent this in a number line. Okay, that one. Okay.
Yes, sir.
What about this one? Negative 10, open bracket, to 20, close bracket.
Draw the number line.
Okay, hello number line.
Our numbers.
Okay, so negative 10, the starting point. 20, the end point. Okay, that's just rough, very rough.
So draw an open circle at 10. We
don't open circle at 10. We don't include it. You are right. And
then we include the 20 since we have the square brackets.
Amen. Square bracket. We include the 20. Then
draw a line.
Amen. Draw a line to connect. You know. Yeah. So this is it. Okay. Then vice versa, if they give you the number line and they say write this in interval notation, then you would write that in interval notation in that way. Then if you have that and they say write your answer, what form is this? Because this is interval notation. What form do they call this? X such that x is greater than or equal to negative 50, where x is an element of integers. What do they call this form? Because this is interval notation, but what do they call this? Do you know?
I think it's set notation.
Did you say it?
Set notation or
set notation.
Set builder. Set.
Very good, nice. Set builder notation. You've got it. My man, why am I even here? Right. Okay. You've got it. You've got it down. Okay. What else do you want from me? Like right now? Okay. Now, I think we can be done with this because like I said, if they ask you to represent on a number line, the reverse question is when they give you the number line and they ask you to either write your answer in interval notation or they ask you to write your answer in set builder notation. So I think you've got a very clear representation here on the screen of those. Okay. Now. I think now we can move nicely to your favorite part. What's your favorite part? Okay, if they say here, simplify. What are you simplifying? Minus 3 into x plus y, the whole thing squared, plus 2 into x plus y, minus 2 into x plus y into x minus 3y for 4 marks. Okay, exam type question. We'll get there, Tweezy. Hey, Tweezy's like, functions, please. Tweezy is dying. So, Landy, we can simplify, ne?
Yes,
we are good. Okay. We are good at simplifying. It's like we don't have problems, Master.
Yes, sir.
Okay. So I'm kind of wasting your time, really. Okay. And 2, we can also factorize all the different types of factorization. We are good. If we are given 4x to the power 4 minus 32x, we know how to factorize it.
Difference. Is it difference of 2 squares or something?
Before that, what do we always ask before we even get
got the highest common factor?
If there is, right?
Yes.
We don't ever rush for others before we check this. That's like spot check number 1. Goes without saying. Yeah. So we always check this, and then after that, if there's anything else inside the bracket, we check if there's any other type of factorization. Remember, other types, we have dots, we have trinomial, we have AT, advanced trinomial, we have drooping, droop, we have common bracket, man, we have cubic.
Yes, sir.
So all these types of factorization, as a grade 10 learner, we need to be so good at everything, and like chow. So here we can say most. Is the highest, we always ask, is the highest common factor? Doesn't matter what we're doing. Is the highest common factor? If there is, take it out. If there's is the highest common factor? And the highest common factor, we know most. We take it out according to this guy.
Signs, number, letter.
Amen. Hallelujah. Praise. So yes. Okay. So are you also crying about functions? Because I almost feel like everybody is everyone's waiting with a bated breath. Like they're like, get rid of this nonsense. We know this stuff. We are wasting our time. I was just trying to help you guys get the basics down, because I don't, I was gonna solve equations, solve inequalities. No. Hey, look at this. I'm in metric. Boo. Like, the thing is, I'm not doing metric here. The person who's here, he thinks I'm doing metric. I'm not doing metric. I'm doing grade 10. It's great. This is a grade 10 learner I was writing tomorrow. So I don't want to be influential in any grade 12 stuff now. I was busy with my grade 12s this afternoon. I think I've kind of had my fair share. Yeah, call Lerato. Lerato is Miss Vocal. Okay. She must extend. Okay, let's start here. October 2022. F of x is equal to negative 2 to the power x plus 4, and g of x is equal to a over x plus 2. Given that g of x has the following property. Who is g of x? What type of function is this, guys? G of x?
Yeah. Is it a hyperbola?
Is it? I sure hope you know it is.
It
You're
is.
100% correct. Don't doubt yourself, especially when you are right. It is a hyperbola. Lerato even confirmed for you in the comment section, a hyperbola. Hello, Lerato.
Hi, sir.
Lira, it's your girl. Okay, so g of x is equal to a over x plus 2. You've confirmed that it's also a hyperbola, right?
Yes.
Okay. Then this one. What type of function is this?
Exponential.
Exponential. So we've got an exponential and a hyperbola. Now they're saying, given that g of x, meaning g of x is the hyperbola, has what? The following properties. 1. The range is y is an element of R where y cannot be 4. That's the first thing. 2. A, meaning this guy, is less than 0. 3. The x-intercept for this function is at 2 and 0. And then 4. Substituting a certain x value in the function leads to a corresponding y value of 6. Okay. And then the question that they're asking is, can you sketch the function below? So can we use these properties and sketch the function? So can I get some guidance.
So, okay. Is our Q value the range? I don't know.
The Q value.
So, yeah, Q value is 4.
Very good. Q value is definitely 4.
Then to find the y-intercept, do we need a y-intercept? No. I don't think we need a y-intercept. Then I don't know.
Okay, so we are being asked here to what? To sketch the function.
Yes, sir.
Okay, and use these properties to do so. But before I go ahead and do that, I just want to show you, want to check if we understand the properties about a hyperbola. So hyperbola function in grade 10, sorry, I nearly did it according to grade 11 here. In grade 10, the hyperbola function has this form: y is equal to a over x plus 2. The a, when the a is greater than 0, in grade 10 you have a solid y-axis and a solid x-axis, of course. But then this q will represent your asymptote. Y is equal to q is the horizontal asymptote. Do you know what an asymptote is, guys? Do you know?
Yes, it's that dotted line they put.
It is that dotted boundary line where the function is not defined. You would not find the function touching that line. So that's the horizontal asymptote. It also has your hyperbola function in grade 10 has a vertical asymptote, which is where x is equal to 0, because that's where the function is also not defined. The other boundary line, but this boundary line, we rarely ever speak about it, but it is, because the y-axis is the line x is equal to 0. Okay, so two asymptotes. If you know the q value, y is equal to whatever the q value is. That's the horizontal asymptote. If you know the value of x that would make the entire function undefined, meaning where x is equal to 0 in grade 10, then that's it as well. Okay, so I hope we are clear here. Two asymptotes, one vertical, the other horizontal. So in this situation where q is not 0, then of course the horizontal asymptote can either be a horizontal asymptote that is above the x-axis, or if q is negative, it will be a horizontal asymptote that is below the x-axis. But the key thing here is that if a is greater than 0, the function is found in the first and the third quadrant. Now, our quadrants are defined according to the horizontal and the vertical asymptote. So when we sketch this function, this is what we're expecting: a arm in the first quadrant and a arm in the third quadrant. This is quadrant 1, this is quadrant 2, this is 3. You know, the asymptote basically defines the boundaries of the quadrant, and this is quadrant 4. So a greater than 0 always means that the function is found in quadrant 1 and 3. In another way, if a is less than 0, same thing. Maybe our asymptote is here, that's horizontal. Our vertical asymptote is always the y-axis. X is equal to 0. So we always write the equations of the asymptotes. Then, if a is less than 0, the function is found in the second and fourth quadrant. Okay. Second quadrant is here. fourth quadrant. Okay, the boundary of the horizontal asymptote, the boundary of the vertical asymptote. Won't touch that line because it's a boundary line. Just like girls and boys have to have boundaries. When we have boundaries, those are safe places where we can maintain or retain our identity. The hyperbola is a hyperbola because it has boundaries, a horizontal asymptote and a vertical asymptote. Boundary lines where this in the first and the third quadrant stay in the first and third quadrant, thus retaining a sense of the identity that it holds. If A is less than 0, the boundaries are the second and the fourth, nowhere else, retaining the sense of identity. So it's very important for those asymptotes to be there. A less than 0, second and fourth quadrant. A greater than 0, first and third. So these are the odd quadrants when A is greater than 0. These are the even quadrants when A is less than 0. The next thing I want to just wrap up on is the idea of domain and range. Maybe I can ask you guys, what is a domain?
A domain is, it consists of X.
Okay.
X, I don't know, but X numbers or something.
X values,
X values.
where the function is defined, or where the function exists or is possible. So where you see the function existing, those X values where the function, okay, those X values where the function is defined or exists or is possible, that is our domain. Okay, that's definition of domain. And the other thing I wanted to ask, what is a range?
The Y values.
Exactly. So same thing, Y values, where what? Where the function does what? Exists or is possible. Okay, it's very important for a grade 10 learner to understand this very well. The Y values where the function exists, where it is possible. Okay, so range is Y values, whereas domain is X values. Now listen to me and listen to me well. I said the vertical asymptote of a hyperbola is in grade 10 always X is equal to 0. I repeat, in grade 10 alone, in grade 10 we are restricted in our vertical asymptote. The vertical asymptote in grade 10 is always X is equal to 0. So if we are talking about the domain of the hyperbola in grade 10, all right, we say when we write the domain that X is an element of real numbers. What does that mean if we say X is an element of real numbers?
X can be 1, 2, 3, 4, 5.
Okay. X can be 1, 2, 3, 4, 5. It seems like you have an obsession with 1, 2, 3, 4, 5. Remember, when we say 1, 2, 3, 4, 5, we are counting numbers. Those are natural numbers. 1, 2, 3, 4, 5. You are actually starting at 1 and you are increasing by 1. In essence, you are actually saying X is an element of natural numbers. That's what you are saying.
It can also be integers.
Okay, it can also be integers. You've extended the family, but you have still fell short of what a real number is if you include the integers as well. There's more to it.
Yeah.
Look at what Twiz is saying. X goes through all the numbers.
Oh.
All the numbers in the number system. No number is left ungone through. So that's rational and irrational numbers. Okay.
Oh.
the entire family of numbers. So I usually like saying that element of R is like saying it's like, for me, it's everything. You know how the ER is there? It's like, for me, it's a short for everything.
Oh.
Yeah, X goes through everything, every number you can think of. All right. So in other words, domain, since it's X values, we are looking at the function from left to right. From left to right. So when we look at the function from the left, look at the function. Here it is. Okay? Goes on forever. The arrow indicates going on forever, but it never touches this line because it's a vertical asymptote. Then there it is again. There from the top goes on. You see? Forever. It will go on forever infinitely, but never touching this line. So where is the function defined? From left to the right? Not here. It's not defined. Where is here? What is this?
It's the
Because it's not defined here.
it's the X.
Careful. This is the
It's the what? Oh, Y.
This is the y-axis. What is the equation of the y-axis? There it is.
Is equal to 0, sir.
Exactly. So the equation of the y-axis is the line x is equal to 0. Are you moving with me here?
Yes, sir.
Yes. So what I'm saying is, when you talk about domain, you are looking at the function. It's like you are moving your pen like this from the left. Defined, 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 defined. Oh, undefined. Defined, 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 defined. You see? So from left to right, defined, defined, defined. Because we are touching the function. Defined, defined, defined. Ooh, on the asymptote where the x is equal to 0, not defined. So the function does not exist just on this line. Okay? But then, after that, defined, defined, defined. It continues being defined infinitely. So from left to right, it is defined. Okay? Does that make sense?
Yes.
Yeah. I hope so. I really hope so. Okay? Because once that is clear for you, then I tell you this, then you will understand when I say the domain of the function is going to be x is an element of R, but x cannot be who?
0.
Yeah. Do you see? This here is the domain.
Yes, sir.
Now, what about the range? Okay, so that would be the same even here, because remember I said this vertical asymptote is like that even here. So here we are moving from the left to the right. Defined, 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 defined. Oh, doesn't exist. Defined, 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 defined. So the domain still is x is an element of real numbers, but x cannot be 0. So in grade 10, the domain is always this. For now, until further notice in grade 11, okay?
Yes, sir.
Until you see another boundary line that's vertical in grade 10, in grade 11. So for now, it's like that. Range, we said possible y values where the function exists. So when we look at range, we are starting from the bottom. Now we here, bottom to top. Why bottom to top? From smallest all the way to the biggest. So I'm going to take my pen and place it like this and move up. Define, 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 defined. Ooh, on this line. Function does not exist. Then on top, after it, defined, defined infinitely. So where are we not defined?
Where y is equals to q.
Exactly. Then when we know the specific q value, then we can actually say, when we write down the range, y is an element of what? Of real numbers. But y cannot be. Now, q is just a general value, but remember, q can be any other number that is real. So we are just going to generalize for now and say q. When I know the specific y value, what do I say? For instance, for this one, these are the properties of the function. We said y, the range is y is an element of what?
Real
And then
numbers, y is not equal to 4.
Yeah, you see, my little. So you were right then, because the minute you saw the range, you saw that this is q, and then you married this q back to the function, didn't you? You saw almost. You said yourself, so sir,
Yes, sir.
q is 4. And I was like, ish, this girl knows what she's talking about. That's why she's saying that.
Yes.
Okay. Yeah, so you know what you're talking about. So is it safe to say that function is fine? It's like you kind of like you have an idea. I think you have a very good idea. So whoever taught you well. I know it wasn't me, but I mean, like, whoever taught you well. Yeah, so we could. So coming back to this. Oh, just before I come back to this, I'm gonna come back to this. Just hang on here. So there are times. If a is greater than 0, what do you see about the function? Is this an increasing function or is it a decreasing function? Look at this. A is greater than 0, right? Look at the function. If you look at the function, what's happening here? From left to right. If you want to read whether a function increases or decreases, read it from left to right. As you move from the left to right, what's happening? From the left, look at this. Look.
Decreasing.
We are?
Decreasing.
Exactly. But a is positive, but here the function is decreasing. Look at here. From left to right, what's happening here?
It's also decreasing.
Yeah, so that means the function is what? All in all, when a is less than 0, it's decreasing. Here, we decrease. We have no choice. What about when a is less than 0? What's happening to the function from left to right?
It increases.
Yeah, you see, it increases everywhere. So here, we are increasing. Okay.
Yes.
Come back here. The range is y is an element of R where y cannot be 4. Can we sketch what that means using that information? Y is an element of R, y cannot be 4. So
Yes,
this is the range, but from this we can write down what exactly. We can draw in what exactly here. If y cannot be 4, that means we can draw in the horizontal asymptote. That means the horizontal asymptote is actually y is equal to 4. We are not told that. We are just told that the range is y is an element of R. But if y cannot be 4, that means y is equal to 4 is the horizontal asymptote. Okay, I'm sorry that you got disconnected there. It seems like a few of you are getting disconnected. Sorry. Okay. Even you, Larat, I'm sorry, hey guys. But hopefully you will let me know in the comment section. If you want to come back on, of course, you can in guest request. I'll have you up again. Anyways, the horizontal asymptote is y is equal to 4. If y is an element of R and y cannot be 4, then it stands to reason that our HA read from this is actually y is equal to 4. That's why y cannot be 4, because that means the equation of the asymptote where the function is not defined, the horizontal asymptote is y is equal to 4. Okay? So we can sketch that in. We sketch that in using the range. But we also know that the y-axis gives us the vertical asymptote. We can write the equation as x is equal to 0. Okay. Then, secondly, Since a is less than 0, remember in this question, we are not told to find the equation. We are just told to do what? To sketch the functions below. So we are trying to sketch the hyperbola below. Okay. Our horizontal asymptote, y is equal to 4. Since a is less than 0, what does that mean? It means that the function is found in the second and the fourth quadrant, since a is less than 0. Okay, very important. Since a is less than 0, function is found in the second and the fourth quadrant. So what we do using this, we can go and sketch, okay, in the second and the fourth. In the second, here we are. Okay, I'm sorry about my curve. It's supposed to be a smooth curve there. Sorry guys, very rough. And then the fourth quadrant. Now remember, we were told the x-intercept is at 2 and 0. So I'm going to go here to 2 and 0. Since 2 is here, then I'm going to sketch the arm in the fourth quadrant using that x-intercept. So I would say that 1, check. A less than 0, second and fourth quadrant, check. X-intercept is at 2 and 0, check. And then here, this is a point that lies on the function x, where x is negative 4, y is equal to 6. So I think when we can say where x is negative 4, y, okay, is equal to 6. We can put that there. Where x is negative 4, y is equal to 6. And then we can say negative 4 and 6. So it stands to reason that one point is defining this arm. Here's another point to define that arm. That's enough information. And then we can say that is g of x. There is the sketch of the hyperbola using the properties that we were given in this particular function. Okay, guys, let me just once again go through these aspects. We first were told that the range is y is an element of R where y cannot be 4. From this, we could see that there is a restriction. The function cannot touch this line. Therefore, that means if y cannot be 4, it must mean that my horizontal asymptote is y is equal to 4, since y cannot be 4. So the first step I usually do when sketching a hyperbola function is I sketch in my asymptote. So my horizontal asymptote I sketched in and I labeled it y is equal to 4. That's step 1. Then my vertical asymptote for this particular function, 6x, since x is isolated in the denominator, that therefore means that x is equal to 0 is the equation of the vertical asymptote, because its domain, if I was to write it down, is x is an element of R where x cannot be 0. That's the first thing. Second, after drawing in my asymptotes, I check what is the value of a, the numerical value of a above the x value. What is a? A is less than 0. What does a less than 0 mean? A less than 0 means that my function is found in the second and the fourth quadrant. What is the second and the fourth quadrant? When you have drawn in your asymptotes first, your horizontal asymptote, y is equal to 4, your vertical asymptote, x is equal to 0, this is your first quadrant defined by the boundaries of the asymptote. This is your second quadrant defined by the boundaries of the asymptotes. This is your third quadrant defined by the boundaries of the quadrants. And this is your fourth quadrant defined by the boundaries of the quadrants. So a less than 0 means second and fourth. So second and fourth quadrant, this is my second quadrant. one arm. This is my fourth quadrant, the other arm. I use the x-intercept, label it as a point for my one arm, 2 and 0 for this arm in quadrant 4. Then, since g, the function, when we substitute in the place of x, which is -4, the output value that we substitute gives us 6, which is the y value. So that means the other point that the function passes through is the point -4, which is x, and 6, which is y, the output value. So then I can label and mark x as -4, where the corresponding y value is 6. That is the point. I mark it on the hyperbola, and there is my sketch for the hyperbola. Finished. Finished sketching the hyperbola using the properties. How simple, how glorious, how complete. Then we come to f of x. Okay? Because we have to sketch this function as well. F of x. Let's go. Let's explain first the exponential function. The exponential function has the form y is equal to ab to the power x, ab to the power x, okay, plus q. This is the form of the exponential function. A here, when it is greater than 0, tells us that the function is above the asymptote. That's what A tells us. Whereas if simultaneously, okay, we know the value of B that is going to either be greater than 1, then this means that when we sketch this particular function, if this is the asymptote defined by the q value, y is equal to q, when a is greater than 0, the function is found above the asymptote, but since b is greater than 1, the function is increasing above the asymptote. Okay, the function is increasing above the asymptote. 2. If a is greater than 0, we know that the function is above the asymptote. But if at the same time b is between 0 and 1, then we know that the function above the asymptote is not increasing, but it is what? Decreasing. Okay, let's get this clear, guys, that a greater than 0 always means that the function is above the asymptote. The function is above the asymptote. Okay, the function is above the asymptote. B is between 0 and 1, together with a is greater than 0, means that the function is above and decreasing. 3. If a is less than 0 but b is greater than 1, what does a less than 0 mean? It means that the function is found underneath or below the asymptote. Okay, so if this is the asymptote, y is equal to q, a is less than 0, b is greater than 1, then the function is what? Decreasing below the asymptote. Because the function a is less than 0 compared to the function a greater than 0 when b is greater than 1. This here is the reflection of this one. Okay. Reflection. Okay. So that's why this one is increasing, whereas this one is decreasing. Okay. Mirror reflection of this one. Whereas if a is less than 0 and b is between 0 and 1, then the function is found below the asymptote still, because remember, a less than 0 means below the asymptote. But if b is between 0 and 1, it means that the function is increasing. Okay, increasing. It's as simple as that. So these are the scenarios for the exponential function. A and b are involved in the position and the manner in which the function is. Is it increasing or decreasing? So as a is greater than 0, above the asymptote. A greater than 0, above the asymptote. B greater than 1 with a greater than 0, increasing above the asymptote. A greater than 0, b between 0 and 1, it's above and decreasing. If the function has a less than 0, it means that the function is below the asymptote. But if it's less than 0 and greater than b is greater than 1, it is decreasing. If it's a less than 0 and b is between 0 and 1, then it is increasing below the asymptote. Clear, clear, clear. And remember, one asymptote, unlike the hyperbola that has two. The one asymptote is y is equal to 2. It is the horizontal asymptote. Horizontal asymptote of the function. Nothing more, nothing less. Okay. So that's why then I want to come back here to this particular function. How do I sketch this? I want to show you guys how we sketch the exponential function. F of x is equal to negative 2 to the power x plus 4. First things first, what is the horizontal asymptote? Y is equal to 4. That's where we start. 2. The 2 is the relationship of a. A is less than 0. Why is it less than 0? A. Remember that this here is b. B is greater than 1. Maybe when you look at this, guys, what you need to very much notice is a 1, negative 1. It's times 2 to the power x. And then there's a plus 4. This is a. That is b. That is 2. A is negative 1. B is positive 2. Because remember, b can either be greater than 1 or between 0 and 1. It can never be negative. And then 2 is actually equal to 4. So a less than 0, b greater than 1. We just looked at the situation. What happens when a is less than 0, b greater than 1? We are decreasing and we are below the asymptote. Decreasing and below the asymptote. So what we know or what we can expect is decreasing and below, like this. We're expecting that sort of shape when we sketch eventually. 3. What else do we know? We can find the x-intercept if it's possible. So let's check if it is. We say in the place of f of x, 0 is equal to negative 2 to the power x plus 4. We take the 4, we transpose it. Negative 4 is equal to negative 2 to the power x. We change, we divide by negative 1. When we do, we get 4 is equal to 2 to the power x. The base exponent is 2 to the power 2. And then when the bases are the same, what do? We equate the exponents and get the value of x. That means x is equal to 2. X-intercept, the coordinates are 2 and 0. What about the y-intercept? We let x be equal to 0. So we come here, we write y. In the place of x, we write 0 plus 4. And then very well put, we say y is equal to negative 1 plus 4, which is y is equal to positive 3. What are the coordinates? 0 and 3. When we have both x-intercept and y-intercept for the exponential function, I think there's nothing more to be said. We just simply go in and 1. We sketch in the asymptote. Y is equal to 4. Then on top of that, after sketching in, we do what? We say that the function is decreasing. We have our x-intercepts. Our x-intercepts are 2 and 0. And last but not least, 0 and 3. And then we are and then we write there what? Okay, there we have it. What more do you guys want, guys? What more do you want? You label the horizontal asymptote, you mark the y-intercept, you mark the x-intercept, the shape of the function. You label it as f of x is equal to negative 2 to the power x plus 4. Then it's like whoever marks your paper is like, yo, this guy. This guy is doing the most. Doing the most for the grade 10s, doing the most. When I do it with you, it seems easy. Then I bless you with a spirit of ease that seems to be incumbent upon you when you are in the live with me. That when you are in the exam room, in the calmness of your mind, the Lord grant you a special blessing, Landio, that you will be able to have the same ease, that the same ease that you have upon your heart and mind right now will be the same ease that will be attendant to you in that exam room. You need that ease. You need that sense of calm and absolute peace so that you can just write what's right and what is. Okay? And these are so sweet as marks, because you get a mark for drawing in the asymptote and labeling it. Please, guys, 2 x y-intercept, 3 x-intercept, 4 the shape, the way it's shaped. 4 marks. 4 marks. Yo, guys, don't say goodbye to 4 marks. Now, let's just go ahead and find the equation. What would we have done had they said, find the equation of the function? Well, first and foremost, we start by writing in the value of q. Okay? The value of q. So, remember, Landi helped us out by saying that this is y is equal to 4. Since y cannot be 4, that is actually y is equal to 4 for the horizontal asymptote. And this 4 belongs there at q. That's what Landi said. The 4 belongs there at q. So let's write the 4 where it belongs. Then we can choose any point. Choose any point that lies on the function. You don't choose a point that doesn't lie on the function. You choose a point, any point that lies on the function. Now think of a point that lies on the function, guys. Any point. Okay? Any point. So we have x-intercept, which is 2 and 0. We have this point, negative 4 and 6. So let's go ahead and substitute 2 and 0. Where x is what? Is 2. And y is what? 0. 0 is equal to a over 2 plus what? Plus 4. Take the 4 over, we transpose it. We take the 4 over, we get negative 4. We have a over 2. Then a over 2 is equal to negative 4. This 2 that is in the denominator, you multiply with a 2 in the numerator. But what you do on the left, you do on the right. So negative 4 times 2 is negative 8. And then this cancels. We get a is equal to negative 8. So that means a is truly equal to negative 8. Now, the value of a that you got, does it make sense in light of the sketch that this guy, that is your sir, drew earlier on? Let's check. Remember, when we sketched the function, we found that the function is found in the second and the fourth quadrant. We know that is when a is less than 0. So, true, it works. Same place with the same function. Therefore, we conclude g of x is equal to negative 8 over x plus 4. Had they asked for the equation, this is how we would get it. This is how we would get it. This is how we would get it. Okay. So from that question, we were able to learn hyperbola and what. I think one other thing that needs to be done is the importance of the exponential function in writing domain. So if you write the domain of an exponential function here, x is an element of real numbers. Domain here, x is an element of real numbers. Domain there, x is an element of real numbers. And then lastly, the domain there is x is an element of real numbers. Then additionally, we say range. What is range? Y is greater than q. The range is above, the function is above this line. Y is equal to q. Same thing here. When a is greater than 0, we say y is greater than q. Okay, we don't include because on this line it's the asymptote where the function is not defined. On this line, range is y is less than q, whereas lastly, with this line as well, y is less than q. So let's get this right and get it down well. Okay. Oh, take it in, my beloved grade 9s. Take it in. Grade 10, sorry. I'm so used to going live for the grade 9s. They seem to not be able to differentiate between the two. Okay. I think 2-minute break. I need a 2-minute break. right. We're back. We're back like never. We're back like never left. Okay, so we're back like we never left, guys. Okay, let's look at this question. This one. The function of m of x is equal to x squared minus 16. Okay. The function of what of m of x? F of m of x is equal to x squared minus 16. P of x is equal to ax plus q is drawn. The function of m and the intersect at g and e. So the function of m and p intersect at what? At g and e. The function of p intersects the what? The y-axis at f, which is 0 and negative 4. AB, this is AB, is parallel to GH. AB is parallel to GH. Here is AB. AB is parallel to GH. And GH is parallel to the y-axis. Okay. It seems like all the information here, the functions of m of x equal to x squared minus 16. Here's the function. Indeed, we can see the form of the function. Now, guys, before I go into this, I want to first and foremost look at a summary of the function of a parabola. Y is equal to a into x squared, ax squared plus q. This a stands for the following. When a is greater than 0, we have a happy face, we are smiling, we're having all sorts of fun. When a, that's a when a is positive. When a is negative, we are sad, it's not even fun. As a result, a greater than 0 means we have a minimum. The minimum value is equal to the q value. Okay. If a is less than 0, we have a maximum, the highest value, which is also given by the q value. Okay. So our a value gives us the shape of the function. Greater than 0 up, concave up or smiling. Less than 0, concave down, maximum. Right. Then q. This here is two things. It's the y-intercept of the parabola. It's only the y-intercept of the parabola in grade 10. It's the y-intercept and it's the turning point. That's why I'm saying in grade 10 and in grade 10 only is it both. The y-intercept and the turning point. This is because of the restrictions placed upon the function in grade 10. Okay. Are we clear? All right. Thank you. So then, this y-intercept, as I said, of the parabola is the turning point as well. Okay. So that's why then when we write down the y-intercept, it's going to be actually the same value that we call as the turning point in grade 10. Okay. Hope that's clear for us. and it's clear very well. Okay. Then let's think about a minute domain and range. The domain of a parabola is going to be x is an element of real numbers. From left to right, that's the domain. Thank you, Anoliolo. Oh my goodness, thank you, Anoliolo. Thank you so much. So from left to right, x is an element of real numbers. As well as this one, concave down. As long as there's arrows on either end, it means that the function goes on. From left to right, x is also an element of real numbers. But its range, if it is a smiley face where a is greater than 0, okay, then the range is y is greater than whatever the q value is. Y is greater than, but it's also equal, because remember, at that q value, the turning point, the function touches the turning point as well. So it is not only found the function above the turning point, but it is also found on the turning point. So that's why we say greater than or equal to q. Or we can say y is an element, square brackets, from q to infinity, open brackets. That's another way of writing the same answer for the range. What about when it's concave down, when we have a maximum? It means that the range, the possible y values, is y less than or equal to q. Okay, so for the parabola, okay, since q is the maximum, it means that the range can be written from the y is from negative infinity to q, but we say y is less than or equal to q. That is the range of our parabola. Okay, very important. Or of course, we could say, by writing it in interval notation, y is an element of open brackets negative infinity to q square brackets. Okay. Oh, that was a storm. Are we clear, guys? Are we good? Okay, I need you to confirm this in the comment section. But remember, you will have a specific value. You're not going to say q. You're not going to say q. You're going to write that value of y at the turning point to infinity. You are going to write that negative infinity to that q value. Amahle. Domain means possible. What grade are you in, Amahle? Possible x values from left to right, where the function is defined, where the function exists. Possible x values from left to right. We look at it from the left to the right, where the function is defined or where it exists. Are you with me now, Amal? Domain is the possible x values from left to right, where the function is defined or where the function exists. Okay. Okay. possible x values from left to right where the function exists. Well, I'm sorry about that. And when are you writing, Amat? Okay, grade 10, sweet. Okay, I hope it's good. Yeah, so that's why we say, for domain of this function, we say x is an element of R. Okay, that's very important that we do that. So let's come here and try and answer now these questions, okay? We are told that the functions of m of x is equal to x squared minus 16, p of x is equal to ax plus 2. So we are given this function of the parabola and what it is, but p of x, we are not given the actual function of the equation. But I expect that the a will be a negative value because this function is decreasing, and I expect that the q value, which is the y-intercept, obviously it's already there. It's waiting to be substituted. It's -4 because that's the coordinates of the y-intercept. The function of m and p. So this is m, this is p, intersect at g. They intersect where? Intersect means they meet at g and e. The function of p, the straight line, intersects the what? The y-axis at f0 and -4. AB is AB. Where's AB? AB is parallel to HG is parallel to the y-axis. Let's see what questions do they have. First question: determine the minimum values of m of x and hence the coordinates of c. Whoa, guys, how cool! We just spoke about minimum. Now they want us to determine the minimum value of m of x and hence the coordinates of c. Now, what is the minimum value of m of x? Okay, if you remember, what did I say about minimum and maximum? I said if it's concave up, the minimum is the y coordinate of q. If the minimum is here, then it's the y coordinate of q. Okay, the turning point. Q here, Q there. So let's go, guys. Let's try and find out what the y coordinate of q is. How do we get that? We go to the function m of x is equal to what? X squared minus 16. Then in order to get this minimum, we are going to, because we know that the y-intercept of the parabola is also the turning point, we know that when we want to find the y-intercept, we let x be equal to 0. So that's like m0 is equal to 0 squared minus 16. So as a grade 9, 10 learner, you know that 0 minus 16 is equal to -16. So I repeat again, what? Determine the minimum value of m of x. Minimum value of m of x is equal to -16. This is the minimum value. Okay. Why? Because this is the y coordinate of the turning point, which is -16. So therefore the minimum value is -16. And then it says, and hence the coordinates of c. This word that says hence, if they are saying hence the coordinates of c, hence means use previous answer. Which previous answer? The answer that you got for the minimum value of -16. Hence, use the previous answer to calculate the coordinates of c. Now c, the coordinates, when x is what? 0, y is -16. These are the coordinates of c. Okay. I repeat again. Since in a parabola, the minimum value is at the turning point, so mean at TP, then we need to find the coordinates of the turning point. How? We let x be equal to 0. We substitute 0 in the place of x, and then we find out the value of y. The y value is -16. Furthermore, the minimum value of m of x is equal to -16. where we've got it, we now need, it says, hence find the coordinates of C. We just substituted 0 into the function, got the corresponding y value is negative 16, and that is the minimum. Then if we want that y value, which is the q value, which is the minimum value, the coordinates thereof are when x is equal to 0, y is equal to negative 16. Those are the coordinates of C. Next, determine the length of ED, determine the equation of P. Determine the length of ED. Where's ED? Here is ED. ET. Where is E found? X-intercept. Where is D found? X-intercept. So x squared, y is equal to x squared minus 16. To find the x-intercept, we let y be equal to 0. So in the place of y, 0 is equal to x squared minus 16. We factorize x plus minus 4. We factorize, this is a difference of two squares factorization. So we factorize x squared minus 16 in its component factors. Square root of x squared x, square root of 16, positive and negative 16. Okay. ED. So x right minus x left. X on the right is 4. X to the right is minus. So on the same horizontal line, x right minus x left is 4 minus minus 4, which is 4 plus 4, which is 8. 8 units. Okay. Any questions arising here? Any questions arising here? What is that no for? Okay, let's go and look at the next question. No question, okay. Next question, determine the equation of P. Okay, so where's the equation of P? Where's P? P is the line ax plus 2. Where does it lie? It lies on the y-intercept. We are given the coordinates. E is just the coordinates that we just got. Okay, -4 and 0. So therefore, what did they ask us to find? We were asked to find the length of P. Sorry. Determine the equation of P. What question did I miss now, Amal? If asked for the range, Amal, for the hyperbola, for the parabola, I explained there. If it's facing up like this, concave up, the range is y is greater than or equal to q. Meaning, in other words, the function is above or equal to this q value, which is the minimum. Okay. If it's facing downwards, your maximum is q. So we'd say the range is y is less than or equal to q. That's all. That's how you go about writing range. So you would have a specific value, for instance, for your q, and you would write that y is greater than or equal to q for your if there's a minimum. Or you would write the answer in interval notation. Y is an element of q square brackets to infinity. Okay. Or in interval notation, if your function is concave down, you can say y is an element of negative infinity, open brackets, to what? To q square bracket. Okay, we good, ne? Hopefully that range answer helps clarify whatever confusion you may have had. Alright, I think now I can move on forward. Determine the equation of P. P, guys, has that x-intercept. It also has E, which is the x-intercept. So f is 0, -4, and E, which we just got, is actually -4 and 0. So if you have these points, E is -4 and 0, while f, which is on the same straight line, is 0 and -4. If you write out the equation, y is equal to ax plus q, the y-intercept is equal to q. So we say y is equal to ax in the place of q minus 4. Then we can take the other point, substitute into this equation to find a. So -4 and 0 is the point we are going to substitute. X, a0 is y. A is -4 minus 4. We can take the a times -4, we transpose it, it becomes +4a, which is equal to -4. We divide both sides by 4, so a is equal to -1. Can't be. A can never. Remember, if a is -1, then that means that function. Sorry. This is the straight line. So a is okay to be -1. It's a decreasing straight line, so our gradient is negative. All right, definitely is negative. Okay, so then the equation, when we finish off, the function of what? The function of p. We say p of x is equal to the a negative x, the q value is actually going to be equal to -4. So this is the equation of the straight line. Okay. Some people could have decided to use the gradient formula, substitute this into the gradient formula, find a. After finding A, you just go and write down the y-intercept, which is -4, as has been stated. Okay. Okay. Next question. Determine the length of OH. The length of OH. Man, for 4 marks. Where's OH? Here is OH. We need that distance. We don't even have the coordinates of H. Look at the coordinates of G. Maybe we will be able to find the coordinates of G, which will lead us to the coordinates of H, and then we can calculate the distance of OH, which is very important. Okay, so let's take it one step at a time. Let's try and find the coordinates of G. What is G, guys? G is the point of intersection of the parabola, which is m of x, and p of x, which is -x minus 4. So we equate the two. M of x is equal to p of x. Then we take m of x, which is x squared minus 16, make it equal to p of x, which is -x minus 4. We transpose. We take the -4 over, take the plus x, the x that's negative over. So we have x squared plus x minus 12 x value, the x and the x, which gives us x squared minus 12. What are the factors of minus 12? If we multiply these factors, they must give us -12, but if we add these factors, they must give us 1. So we have plus 4 minus 3. And then final answer, x plus 4 is equal to 0, or x minus 3 is equal to 0, which means x is equal to -4, or x is equal to 3. Okay, there we have it. Easy does it. But this x is -4. Okay, and this x is +3. So I'm beginning to believe that the x coordinate for G is 3. Okay, the x coordinate of G is 3. You know, and then the y coordinate we would actually go ahead to find. So the x coordinate of G is 3, right? And then we take that x is equal to 3 and substitute into 1. P of 3 now H is actually equal to 3 as well. I don't know what oh